Hello all, this is Saritha here. Today I'm going to discuss logarithm application in advanced questions. Stay with me till the end of the video so that the content is useful to you. And if you're a new user, please like, share and subscribe my channel. So let's discuss the topic. So we are already familiar with the general properties of log, in which a raised to log x to base a is equal to x, and another property x raised to log y to base a is equal to y raised to log x to base a. So the students who are preparing for advanced level, JEE advanced level, they will be familiar with both of these properties. But what I'm trying to give you here is there is also one more result which can be made as standard and used. That is x raised to under root log y to base x is equal to y raised to log x to base y. So this is a new property. Let me prove this property with an example here and the direct application of an example. Let's say I'm having 5 raised to under root log 4 to base 5 minus 4 raised to log 5 to base 4. So if the question is to find the value, find the value of this expression. So if you look at the above property, I think the difference of these two should be 0 here. But how is that I can prove? Suppose if I consider the left hand side, first expression, under root log 4 to base 5. You can multiply and divide with the root of log 4 to base 5. So what happens inside the base? It's 5 raised to log 4 to base 5 whole power 1 over log 4 to base 5 under root. So the base becomes now 4. And whenever I wanted to interchange the number and the base here, I can write this in the numerator. So since we have proved that 5 raised to root of log 4 to base 5 is same as 4 raised to log 5 to base 4, so the difference is 0. Let's see another application of the same property. Suppose I have 3 raised to root of log 8 to base 27 minus 2 raised to log 243 to base 32 minus 5 raised to log 9 to base 25 plus 3 raised to log 25 to base 9 plus root 2 log 9 to base 2 plus 3 power log 25 to base 4 minus 5 power log 9 to base 4. So to find the value of this, apart from the previous property, we can also use another result here, that is log of a power p, b power q can be written as p by q log a to base b. So this is a well-known simple property of log. So when I use this, the first expression changes to 3 raised to log 2 to base 3 under root minus 2 raised to, because 243 can be written as 3 power 5, and 32 is written as 2 power 5. So it's log 3 to base 2 under root minus 5 raised to log 3 to base 5 under root plus 3 raised to log 5 to base 3 under root plus root 2 raised to log 2 to base 2. So what is the value of this? Completely root 2 only, because log 2 to base 2 is 1 plus 3 raised to log 5 to base 2 minus 5 raised to log 3 to base 2. So according to the previous property, I think most of the terms I can remove it here, and these two are equal. So these two are equal. So these two are equal. So finally, the value of the expression is going to be root 2. So when we know the property, it is one step working where you can cancel the identical terms and simplify the remaining. And to create a more advanced level question, apart from log properties, if I'm using quadratic equations concept also, let's see another question. Find the value of A or values of A for which the quadratic expression ax square plus a minus 2 plus 3 times root of log 5 to base 3 minus 5 times root of log 3 to base 5 whole term into x plus 5 raised to log 3 to base 5 minus 3 raised to log 5 to base 3 is equal to 0, or this expression is negative for exactly two integral values of x. So we are supposed to find out the values of a here, for which this quadratic expression is negative for exactly two integral values of x. So according to the property, we know that 3 raised to root log 5 to base 3 is same as 5 raised to root log 3 to base 5. So the expression will change to ax square plus a minus 2 plus 0 into x. And we also know that the last two terms of the expression is going to be 3 minus 5, which is equal to 0. So simplifying this expression, you get ax square plus ax minus 2x minus 2 is equal to 0, so which can be further factorized as x plus 1 into ax minus 2. So if I'm equating it to 0 to form a quadratic equation, this quadratic equation will have two roots. Let's say if I'm drawing the graph with two roots as minus, one of the root is minus 1, the other root is 2 by u. So according to the question, there exist two integral values between the roots. I mean, the expression is negative for exactly two integral values of x. So after minus 1, what are the two integral values we can have? 0 as well as 1. So from this expression, we can also say that since it's exactly two integral values, 2 by a should lie between 1 and 2. Or you can also write a by 2 will be in this form. So this should give you the a values are lying between 1 and 2. So in this question, we just need the values of a, but we are also using the log properties here. along with the quadratic expression properties. Since a quadratic expression is negative for exactly two integral values of x, and we also got one of the root as -1. So after -1, there will be two integers, that is 0 and 1. And other root becomes 2 by a here. So now 2 by a should be more than 1 and less than 2. 2 by a cannot be very far from 1. If it is far, I will have more than two integral values between the roots, which will deviate the question. I hope this explanation is clear to you.